The last decade of orbiters, landers, and rovers have given us an unprecedented look at the Mars surface. So let's take a look at Mars up close. Here's a typical Martian feature. The craters that are seen all over Mars, in this case superimposed with a gorgeous sand dune, textured by the winds that circulate on the surface, sometimes at over 100 miles an hour, occasionally whipping up dust storms that are larger than the United States. A mission operated out of the University of Arizona by the Lunar and Planetary Lab has been taking extraordinary images at close to 1 meter resolution across most of the surface of Mars. The altimetry from the orbiters can be used to recreate realistic three-dimensional trajectories across the planet, as if we were swooping over these surface features. Two of the most extraordinary missions sent to Mars are small, no bigger than a child's go-kart. They're the Spirit and Opportunity Mars rovers, which in each case have done their work for over 6 years, and one of them continues into its 8th year. These missions were only designed to last 90 days and travel less than a mile. They've outdone their spec by an order of magnitude or more. Extraordinarily successful missions. Identical hardware that has suffered quite different fates on the Martian surface and had different adventures. Spirit and Opportunity did not provide the first evidence of water on Mars, but by looking at minerals up close and doing chemical analysis, they've cemented the idea that the Martian surface at one point had water on it. First, let's celebrate Spirit. Spirit unfortunately finally met its end. After working its diamond bit so much that it was blunted and having one wheel that didn't work such that it had to drive in reverse, eventually Spirit got stuck in a sand dune and was immobilized. It was turned off and converted into a stationary science station a year or so ago, and finally communication with Spirit was lost in early 2012. Opportunity, its twin, continues its work into its 8th year, having traveled an extraordinary 25 miles across the Martian surface. And although we might have a mental image of someone at Houston Space Center with a joystick and a cowboy hat on careening over a sand dune with a rover, in fact these rovers move very carefully and methodically, rarely traveling more than the distance of a football field in a day.
It's been 7 years since the rovers landed on Mars. This was originally a 90-day mission, only 3 months.
The fact that they've lasted this long and driven this far was in nobody's imagination.
Opportunity has crossed almost 26 kilometers of odometry, and it's still in very good health. That's amazing after 7 years.
Opportunity's in kind of a desert trek mode ever since we've left Victoria. Opportunity now is located at Santa Maria Crater,
It's one of the freshest craters that either rover has had a chance to explore. And there's also evidence of some hydrated sulfate minerals around the southeast corner of this crater.
They can only form when there's been water along for a really long period of time.
The next big adventure for that rover, and that's to get to Endeavour Crater, which is a giant crater that's still some 6 kilometers away from where the rover is right now.
We're trying to do a balance of driving as fast as we can, but making sure we don't miss anything critical as we drive. Endeavour is such a large crater, we might start seeing rocks ejected from Endeavour well before we get there.
That's our next big objective, because we know there are these clay minerals present in the rim of Endeavour Crater that is suggestive of ancient water on Mars that was of neutral pH. Neutral water is what astrobiologists assess that life started in, and so the fact that there is evidence of ancient neutral water on Mars is very exciting for the biopotential of the planet.
It's an exciting time over the next year or so while we get this underway.
Phoenix, out of the University of Arizona, was the first time that NASA trusted any university to operate an entire mission except for the launch. This project also brought a $350 million contract to my university. Phoenix was based on a design that actually led to a failed mission that plunged into the Martian surface. They resuscitated the design, got all the bugs out, and did a very successful launch to the polar region. Phoenix was not a rover, it was a fixed platform, but it actually watched the hydrological cycle in operation. In fact, briny material was seen dripping down the leg of the lander. When water has sufficient amount of salt or other minerals, it can be liquid even at the cold Martian temperature. It also saw a fine snow falling on one occasion, an extraordinarily successful mission. Our current rover on Mars, Curiosity, or the Mars Science Lab, is just beginning the heart of its mission after an adventurous and successful landing. Curiosity steps up the size, the scale, and the degree of difficulty of a Martian rover. Compared to Spirit and Opportunity, the size of go-karts, Curiosity is the size of an SUV. Spirit and Opportunity landed on Mars in bouncing balloon bags, which were rather sensitive to problems of the landing because they bounced to a halt, protected by the balloons. Curiosity, by contrast, used an audacious sky crane method, which seemed to have many ways that it could go wrong, and yet it didn't. Planetary scientists argued for years about where best to land on Mars. If you have $1 billion piece of hardware with no twin ready to go if it fails, you better be sure where you want to land it. In a series of conferences over 3 or 4 years, they narrowed down from 100 to 25 to 4 and finally to 1 landing site. Think of it as a roulette game where you have to put all your money on one number. The scientists chose Gale Crater because there's strong mineralogical evidence that the Gale Crater was once a shallow seabed. Minerals seen there are similar to the clays and silicates that are seen in terrestrial regions of sedimentation, leading to the exciting prospect that the Curiosity mission will be able to further give evidence of Mars's wet past. Mars is busy enough with missions that the missions take pictures of each other. Here's a picture of the Curiosity landing taken by the main Mars orbiter at the time. The Curiosity descent sequence was enough to give gray hairs to all the people involved in the mission. It was a complex sequence involving using the heat shield to decelerate through the thin Martian atmosphere, the deployment of a parachute, the separation of that heat shield, and then the scary part, lowering the rover on metal ropes and then deploying a sky crane to gently lower it onto the surface while the spacecraft maintained an altitude of about 50 meters. Then those cables were released and the spacecraft flew off to crash land in the Martian surface. There were at least 6 or 7 places in this sequence where one mistake would have spelled doom to the mission. I've heard Peter Smith, the PI on the Phoenix mission, describe what it's like in the control room when a mission like this lands. Essentially, each group of engineers responsible for one part of the landing sequence is anxious and then celebrates as their part is concluded successfully. And then all eyes pivot to the next group. Basically, we didn't screw up, now it's your turn. Eventually, the baton is passed to the last landing stage, and Curiosity landed on the surface, the softest possible landing imaginable.
Things are looking good. Coming up on entry. Vehicle reports entry interface. We are beginning to feel the atmosphere as we go in here. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. The parachute is deployed. We are decelerating. Teach has separated. We're on the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers descending. Standing by for backshell separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane is started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars.
Got thumbnails.
Curiosity is working slowly and methodically and has a wonderful suite of 12 instruments, which will give detailed information on the chemical situation and history of the rocks that it studies. It's important to remember that Curiosity was never built as a life detection experiment. It will not look for DNA or nucleic acids, and it will not really be able to tell if there are microbes hidden in the rocks. For that, we'll need sample return. But it's clearly a step up from the much smaller rovers that preceded it, and its mission could last at least 2 years and perhaps as much as 5 years. Mars is the watering hole, so to speak, for a wide range of NASA missions. We've had orbiters and landers around Mars since the mid-1970s, but the current generation are doing extraordinarily detailed work. Mars orbiters can resolve everything down to the size of a football, and they can map the entire surface, not just in visual light, but in radar, able to detect subsurface water. The small and extremely successful twin rovers Spirit and Opportunity, one of which is still doing its work, have been superseded by the Curiosity rover, the size of a small car, just beginning its scientific mission.